Hi, good evening. This is Daryl Barnes with BarnesBasics, and we're going to continue in our Kinematics series. This is problem number 3A. It, like the other ones, is based on a video that I have, and this one is suspected entrance to Sasquatch Den, I think. Look for that one as a link in the comments after this video, and you'll get to see kind of what inspired me to do this physics problem right here. Also remember to make sure that your calculator is configured, your TI-84 Plus and your TI-Nspire CAS. Make sure that across the top on the TI-84 Plus it says normal, fixed 6, decimal, real, degree, and MP. And then on the TI-Nspire CAS, when you're on the home screen, if you click on settings and then document settings, make sure you have selected float 6, degree, normal, and approximate, and apply that to this document and everything will be good to go. On your TI-Nspire, make sure you check or you select the bottom left multiply, divide, minus, and plus. We're not going to use the scratch pad, we're going to use the document. So here's how the problem reads. It says a large bipedal furry creature approaches to the north toward your position with the initial velocity of 2.5 meters per second and an acceleration of negative 0.50 meters per second squared. It uniformly slows down for about 5.0 seconds. What is its final velocity? Showing you the formula that we're going to plug into in just a minute. Let's read the problem though and try to determine what kind of variables that we have. We know that the monster is moving north and the velocity, the initial velocity, is 2.5 meters per second. So let's say that the initial velocity is equal to 2.5 meters per second and it's to the north. Says it has an acceleration of negative 0.5 meters per second squared. So let's put that in here, negative 0.50 meters per second squared. And it uniformly slows for 5 seconds. So that would be time. Time is equal to 5.0 seconds. Since it's accelerating in the same direction, or decelerating is a better way to say it, in the same direction of the velocity, we'll also just go ahead and put north here to denote that as a vector quantity. So we have an initial velocity, we have acceleration, we have time, and the question is, what is the final velocity? So VF is the question mark. That is what we're trying to find. So we have a wonderful equation here that's just a rearrangement of the acceleration equation, and we can plug chug and crank here and should come out with a number pretty quickly. We can see that the initial velocity is 2.5 meters per second and the acceleration is negative 0.5 meters per second squared, and then the time is 5.0 seconds. Why don't we do like that? So in the equation we have picked out 2.5 meters per second for the initial velocity. We have an acceleration of negative 5 meters per second meters per second squared. The time is 5.0 seconds, and so let's put this in the calculator and see what we come out with. Let's see what happens here. So we'll go with our TI-84 Plus, and let's solve this little part right here. Let's say on and clear, and we're going to say 0.5, and down at the bottom right of the keypad we're going to hit the negative button. That's not going to work. Hold on a minute. All right, let's start over again. Down at the bottom right of the keypad, let's put negative and then 0.5 and then multiply by 5.0. If we want to make this really correct, why don't we put 0.50. It's not that big of a deal, but let's don't confuse anybody. Negative 0.50 multiplied by 5.0 and hit enter, and we get negative 0.25, we get negative 2.5, and we get about 5 zeros. 1, 2, 3, 4, 5. And also notice that we have seconds over seconds. We have meters per second left over. So let's put meters per second here. And then we have a 2.5 meters per second. And we're going to add a negative 2.5 to that. So what happens if you have a positive and you, in effect, you subtract the same number? We have the same unit, so we can do that. So a positive 2.5 and a negative 2.5 equals what? 0.0 meters per second. And we know that this monster was traveling north, so we might put north. So we could say that 0.0 meters per second in a direction of north. We can circle that as our final answer. So we didn't really even have to use the calculator for the whole operation, but because it was kind of something in our brain, kind of intuitive. Let's try this in the TI-Nspire, because this one, the issue on this problem is getting the negative into the number. So the same thing, at the bottom right of the keypad is the negative. So let's say negative 0.50 multiplied by 5.0. Let's hit enter. I got negative 2.5. The TI-Nspire is not giving me all the trailing zeros, and we'll talk about that in just a minute. But in this case, we'll go ahead and add it. Let's say plus, only once, hit delete, plus 2.5 and hit enter, and I get 0 meters per second. So basically this furry monster screeched to a halt. Slow down to nothing. So the Sasquatch just stopped right in front of us. And the next problem will kind of pick up right here where this problem stops. Now, let's talk about sig figs for just a second. In this problem, there are 2 sig figs with 2.5. There are 2 sig figs with 0.50, excuse me. The 5 is a whole number, so it's significant, and the 0 is to the right of a whole number and it's to the right of a decimal. It's significant. Whole number is significant. 0 to the right of a whole number and to the right of a decimal, that's significant. So we're dealing with about 2 sig figs, and I don't really know that this is so important in this problem to say 0.0, but we can always do that to show that we knew what was supposed to happen. We are showing at least 2 digits here. So in this problem, the monster's coming at us, but he's slowing down. He comes to a stop, and that's going to lead us into the next problem. So right now, look for the video called Entrance to the Sasquatch Den. It'll be something like that. So we'll pick up on this next time.